All right, so again, what we will test tomorrow, just 1.1 through 2.1, only through example 8. So no absolute value functions and no piecewise functions. So if you look past example 8 in the notes, you'll see like y equals, 5x minus 15 over x minus 3. You won't have any of those. And then the other ones that are piecewise look like this, like x squared when x is less than 1, 2x plus 1 when x is greater than or equal to 1. You won't have any thing like that. Okay, so just through example 8. So your warm up here, you got a polynomial over polynomial on your free response again. It may look more something like this. Let me back it up here. Let's say that I have g of x is equal to 2x squared plus 9x minus 5, and h of x is x cubed minus 25x. Find f of x equals g of x over h of x, right? So that's how it was on the last test, which is pretty much the same question. You're just having to set it up. And it'll say, write the equation, right? So when it says equation, make sure that you have whatever I name it. F of x equals, k of x equals, r of x equals, w of x equals. It was all of those on the last test, because that might be worth a check. And sometimes even if it's not worth a check, if you don't have it, you can lose the check. Okay, so anytime you say something incorrectly, like Woody standing here saying to infinity and beyond, right? That would lose the check, because that's not what Woody says, right? Unless he's making fun of Buzz Lightyear. So anyway, you would set it up, we'd get to this point, and then like part B would be like find the domain, all right? So let's do that first. We'll call this part A. Ugh, I can't even make my A's. A, there we go. And then this would be like B, okay? B. So find the domain, or this would be part B. Man, I'll get there. I'll get there. I'm not worried. I'm just concerned. Okay. So find the domain. What do we know about the domain? We know that x cubed minus 25x can't equal 0, right? It's a denominator. There's no radicals here. So from there, we would factor it, right? It's equal to 0, and it's an equation or a non-equation. So we can use algebra. Very good. Uh-huh. It's a difference of squares. Yeah, good. So x plus 5, right? Still can't equal 0. So that's another thing to remember notationally. Once you set up an equation, you got to keep an equation or a non-equation all the way down. So don't leave off either side. You come back and check before you walk away. And now we'll use that factor theorem. We won't go through the process of actually setting each of them equal to 0, unless you want to. You should be able to look at these three factors and run off the roots, right? X equals or can equal 0. I'm going to go from left to right. 5 and negative 5, right? This goes with that, this goes with that, and this goes with that. Guess which one most people tend to leave off accidentally, of course? The 0, right? Because that X is in front, all innocuous like. He's not making a big stink. He doesn't have parentheses. But remember, this is the same as parentheses x minus 0, okay? So imagine setting each of these equal to 0. X cannot equal 0, and then you have that. X minus 5 can't be 0. X plus 5 can't be 0. You set them each equal to 0. Okay, so there's three discontinuities. These are all discontinuities because the graph lives immediately to the left and right. All right, so to write the domain, we would then say d sub f is the set of all x such that x cannot equal. And then, of course, we can list these in any order: 0, 5, negative 5. They don't have to be in increasing order when you write them in set notation. Now, when you do interval notation, they do, right? So let's go ahead and do that. Or x epsilon, we would start at negative infinity, cruise to negative 5, union negative 5 to 0, 0 to 5, and then 5 to infinity. So there's 3 cal patties we got to step over. Now, when I was looking at that other review sheet for domains that we had like the week before, there were a lot of people that were setting up their quadratic inequalities and then trying to solve them algebraically. Remember, if it's an x squared and there's an inequality, you have to solve it graphically. It's either going to be between the x-intercepts or outside of, okay? Not both. But that's not the case here. We don't have an inequality. All right, so then part C would be, now of those 3 values that are discontinuities, are they holes or are they VAs? So part C might actually be not that. Part C might be this. I'll just kind of stick with the same format. Write f of x in simplified form. iPads make this real easy, right? Before we were using like paper, students would have to like erase and move things around on their paper and they'd be like, ah, I wrote it down. Now you can just like, oh, no big deal, right? I'll just move it down. It's nice.
Technology is a wonder.
It is. It's magic how I can stand over here and it shows up over there. Now, simplified form would basically be factored form with anything divided out. So let's go ahead and write it first of all in factored form. We'll do that first, factored form. Because factored form is on the road to simplified form. F of x equals, we know the bottom already is x times x minus 5 times x plus 5. And don't forget the f of x equals. Now I got to factor the top. Well, hot diggity donut. Diggity donut. The leading coefficient is not a 1. Hooray, hooray. This is an honors class. Don't give us those easy lob pitches, Mr. Corpy. Throw us something that's supposed to be challenging, but still easy to hit, like a Garrett Cole pitch, right? Am I right? Oh, yeah. Yeah. Astros are up 2-0 or 3-0? 2-1. Oh, really? I see. I didn't get to watch that. I was on like total, like my wife is a registered nurse and she was like, you're not doing anything this weekend except breathe. And I'm like, fair enough. Yeah, so 2 is prime. It's got to be a 2x and a 1x. Now, if you know how these problems set up, hey, maybe, just maybe, one of the other factors is an x plus 5 or an x minus 5. You think? You think maybe? Because maybe then it would divide out and maybe we'd have a hole there. So just maybe, maybe. Yeah, let's try it. So let's try this as a 5. Let's try this as a 1. And now we just need to make sure we get a positive 9 in the middle. So it's got to be a plus 5 and a minus 1. So you can go off to your side on your workbench. You could FOIL it out, and you could see that it works. Hey, so that's factored form. And now simplified form, and this is Mrs. Lincoln's term. So I kind of like it. I wrote the instructions on that review. I told you what simplified form was, I think, maybe I didn't. But simplified form is useful because that's the one we plug into to find the y value of the whole. Now, I'm not going to call it f of x anymore. I'm going to call it just plain old y. And I'll explain to you why here in just a second, if you don't already know. Do your math homework. If you go like this, I'm not going to take off. Because if I want to see the factored form and I can still see the factor underneath there, that's good, right? So like on a written test, don't obliterate it. I need to be able to see that there was an x plus 5 there. So the simplified form then would just be 2x minus 1 all over x times x minus 5. And you don't even have to show the line for the dividing out. You don't have to. I think on the key that I posted on Friday, after I left here, I didn't divide it out showing it. All right, now what we do here is on the back end of the simplified form, and you could draw the line through it again. I'll just put it back in there. What value of x do we need to warn people now not to use? Right, just that -5. We don't have to warn against using 5 and 0 because that's still a built-in thing. Those 2 factors are non-removable, so we still can't use them. But the x plus 5 was a removable factor, so its root is a removable point discontinuity. Okay, now part D is going to be name and find any discontinuities. All right, so let's do the 2 non-removable first because I think they're easier, right? The 2 values of x that still make the simplified form 0 in the denominator are what? What's the root of x? 0. And what's the root of x minus 5? 5. So at x equals 0 and at x equals 5, the function f has what? Non-removable infinite discontinuities, or VAs, vertical asymptotes. Feel free to call them VAs, right? So in a complete sentence, f, or f of x, has VAs, that looks like a U, has VAs at x equals 0 and x equals 5. You do want to list them separately. Don't put 0, 5. Because now we're not just listing x values, we're listing two separate equations. X equals 0 is the vertical line, okay, not just that x location. It's the entire vertical line. Yes, sir?
I thought if they cancel out, they
No, no, because if they cancel out, which is not really the right term, Brady, forget you teaching, divide out, they're removable from the equation, right? And if we can remove them from the equation, they are removable point discontinuity. So that was that parallel. Remove the factor, removable point discontinuity. Non-removable factor, non-removable infinite discontinuity. Okay? And a hole, what's the proper name for a hole, Elma?
hole.
What's the proper name for a hole? Yeah, okay. Removable point discontinuity. Okay. I might actually say, have you write that. That sounds like a good pre-response question. What's the proper name for a VA? What's the proper name for a hole? Removable point discontinuity is a hole, and a VA is a non-removable infinite. Perfect. That's a great pre-response question. And a hole at, now we list the hole as a coordinate. It's at -5, comma, and then how in the heck do we find the y value at the hole? Plug it, the antecedent to it is -5, yes. Plug it into which equation, f or y? The simplified form. And I did write that note on that review. I said, use this on the key, use this to find the y value. So even though it says, hey, don't use -5, we're going to use it, right? We're going to plug that knife into the electrical socket when they tell us not to. Hey, let us learn the hard way, right? But we know that we're not saying that the graph exists there. We're saying that the graph used to exist there until someone stole it. Now, I'm going to do that off to the side. You could either say y of -5 equals, and then plug it in. This is on your workbench over here. So off to the side. You could say 2 times -5 minus 1 all over -5 times -5 minus 5, and then simplify. Or you could say at x equals -5 colon. Okay, and then you can just plug it in. So remember, you should always be indicating what you're doing, indicating your method, communicating your result. This is why I don't want to call it f of x. If I called it f of x, I couldn't say f of -5 there. Because remember, f of -5 doesn't exist. So that's why we want to call the simplified form just plain old y, or give it another name like j of x, whatever you want. Okay, I'm just going to keep going with this version here at the top. But indicating your method, let me go ahead and circle this or box this. This is called indicating your method. Indicate your method. Okay. When I was taking defensive driving, like each of the 5, 6 times I've taken it to get out of speeding tickets, right? I know. Back when I was a college student, and my wife was at a different university than I was, and I had to get to her quickly, you know, because young love. They always said, hey, when you're driving your automobile, be safe, don't speed, and signal your intention. Signal your intention, which is a nice way of saying use your freaking blinker, right? Use your freaking blinker. That's what they're for. If there's someone behind you, use your blinker, right? To signal your intention. Same thing here. Indicate your method is signaling your intention. Using your blinker. You're telling me what you're doing. I would not recommend speeding, okay? Especially in college when you're strapped for cash anyway. But yeah, you can only take defensive driving so many times. Then it's called deferred adjudication. Now my wife is in my house, so I just have to speed from one room to another to get to her, but no cops there. Old love. What do we get in the top? Negative 11 over, oh, there's a lot of negative 5s down there. Be careful. That's a negative 10 on the inside, and a negative 10 times a negative 5 is a positive 50. So that doesn't simplify because 11 is prime. That's not a very pretty number, but you know what? Don't say that out loud because it'll hear you. It is a number, and we accept all kinds of numbers in here. We love all kinds of numbers. Everyone good on how to find the y value of the whole? Pretty easy. Plug it into simplified form, but tell me how you do it. Tell me how you do it. Now, if we had more time, you know, before tomorrow's test, which we won't, we'll do this after the test, we would actually combine this information with a couple other things from algebra, and we would sketch a graph of this function without a calculator. But we're not going to do that. This would be as far as you go on this test. Sound good? Yeah. Yeah. Now, there's one last thing that I'll mention here. I'm not going to put on the test, but what about the other value now that makes the numerator 0? There was originally 2 values that made the numerator 0. Negative 5, which factored out, which was a whole, and 2x minus 1, which is now remaining in the top. Its root is what? What's the root of 2x minus 1? Set it equal to 0 in your head. Add 1, divide by 2. 1/2. So at x equals 1/2, when you plug a 1/2 into the simplified form, you get 0 over non-zero. What is 0 divided by any non-zero number? 0, right? So when you plug in a 1/2, you get out a 0. Guess where that point's going to land? Some number, comma 0 is always going to live on the x-axis. Yeah. If you take your simplified form and set it equal to 0, by setting the numerator equal to 0, what's left? You get the x-intercepts of this function. Okay? That's just kind of planting a seed. We're not going to do that on this test. Our goal is eventually to put all this information together to come up with a nice looking picture of this, all right? But if you have this right here, this might be part of your free response. I might give you a quadratic and have you throw it under a radical and find the domain that way, because I'm still not convinced everybody knows how to do that. But this would be a big chunk of your free response. And this is what that first part of the review that y'all worked on. Hopefully I'll work on that Friday, maybe. You know, into Miss Dawkins' room. Yeah, good.
I got it done on Thursday.
Oh, that's fantastic. Yeah, my goal was to go over that on Friday, but.
Although it was completely wrong, remember he said.
Uh-oh. Well, we're going to go over that now. Any questions on the warm-up? All right. Well, let's pivot here. Transition to.
As you can see, I messed up.
As long as you know where you messed up, why you messed up, so it doesn't happen again. All right, let's go through it quickly. I have the key already posted. I posted it in Canvas, but I'm just going to go over it with y'all, okay? So if you have a question, just a holler, okay? All right, so again, this is kind of written in kind of a segmented way to guide you towards the answer so that you can be successful. You have a function f, it's already set up, but again, on the test, I can say, let the numerator be g of x, let the denominator be h of x, and then what is f of x equals g divided by h, and then you would write that, okay? Factored form, factor the top, factor the bottom, boom. Find the domain. I'm gonna work straight down and then go to the next column, because once it's factored, domain is easy. I'm not going to require at this point that you set the denominator not equal to 0, okay? Once it's factored, you don't have to say anymore, denominator can't equal 0. I did that in the beginning to force you into thinking what we're looking for. But once it's factored, at this point, I would rather you look at the factored denominator and just say, hey, x can't be -7, x can't be -1. So now, as long as you have that identified correctly with the right notation, here, as Harry Styles says, golden, golden, as I open my eyes, like I finally did in 6th period last Wednesday. Did y'all know I passed out in 6th period? I was sitting right there and I was talking, and then the next thing I remember, the tardy bell rang. Yeah, I had a mini stroke and they thought I was sleeping. So, wow. Blood pressure went up, pulse dropped, no oxygen. It was strange, yeah. I had 2 last Wednesday, the doctor said. So early catch. The NFL is doing the critical catch for like cancer, but this was a good catch. This was a good catch health-wise for me. So new diet, new medications, new doctors. Life is about experiencing new things. Lots of new things as you get older. All right, so you could write it in either one of those, set or interval, interval or set. I don't care as long as you have the right notation. If you don't have D sub F colon, you're going to lose a check. That's going to be really sucky for you if you have the right thing written out on the right-hand side, but you forget D sub F, okay, or D. I don't care if you put the sub F. It's nice, but you need big D colon, all right? So make sure you have that locked in there. Now that we know that it can't be -7 or -1, those are discontinuities, their holes are VAs. So write it in simplified form. Oh, I did say if anything divides out. I did put that there. Yeah, the x plus 1's divide out. So there's the simplified form. Again, notice we're calling it just plain old y. Plain old y. And then you make a comma. Hey, we lost the x plus 1 factor, so don't use -1. And then I said, hey, use this to find the y values of the hole. So that's what it says next. If there's any holes, find it. If there aren't, you know, it's a little bit differently worded than what we did on the warm-up where I said name any discontinuities. If it specifically says find the coordinates of the hole, if there are any. If there are not, you just say no holes, okay? X plus 1 divides out, so x equals -1 is a hole. You don't have to write that on your test. If you want to, that's great. I put that knowing that I wasn't going to be here to talk you through it. You looking at the key, that'll help you remember. What I'm going to be looking for is this. I'm going to be looking for, are you indicating that you're plugging in that taboo value that divided out into the simplified form? Are you indicating it as well? Not just finding it. If you just come up with -1 as the y value and you don't tell me where it came from, in this case, I might think you're just repeating the x value, right? So you indicate it. You either say at x equals -1 and then you show me, or you say y of -1, kind of like function notation. In this case, it does come out to be -1. So the x and y coordinate are the same. All right, and notice what I wrote over here. I do expect complete sentences. So, or therefore, I usually put a comma after that. So f has a hole at the coordinate at the point -1, -1. All right. And then again, what I'm going to be looking for, I'll highlight what I'm going to be, bless you, looking for. All right. There you go. X plus 7 did not divide out from the denominator. I wrote that to help you on Friday when I wasn't going to be here. You don't have to write that on the test. I'm just going to expect you to say, hey, F has a VA at x equals -7. Piece of cake, right? Now, what if you just said F has a VA at -7? What if you left off the x equals? You just said VA at -7. Is that good? Full credit? No, 0 credit. Like, so close. What if you say VA at y equals -7? That's a horizontal line. That's no good either, right? So make sure you say at x equals -7. That's the equation of a vertical line. It's no longer just an x value location. It's an equation of a vertical line. Okay. All right. Any questions on that? I mean, that's pretty straightforward. Just for kicks and giggles, what are the x-intercepts of f? What are the roots of the entire function f? Well, you look at the simplified form. Are there any values that make the numerator 0 after you divide out anything? 5. Yeah. If you plugged in a 5 to the original function, you could use with simplified form for everything else regarding the function once you identify the hole. So f would have a hole at x equals, or sorry, an x-intercept at x equals 5. Okay, 5, 0. Setting the numerator equals 0. That might be a good bonus question on the test. Find the x-intercepts of f. Indicate your method. Oh, wow. Right, I know. Remember, a fraction is equal to 0 when the numerator is equal to 0. Remember that? Let's kind of just go through what that would look like. Like find the zeros of f of x. Well, you would say f of x equals 0. And you can use the simplified form, right? X minus 5 or x plus 5 over x plus 7 equals 0. And now instead of multiplying both sides by x plus 7, remember we talked about this in class, a fraction is equal to 0 when the numerator is equal to 0, which is at x equals -5, okay? Comma, so f has an x-intercept or a root or a 0 or whatever you want to call it at, and I'm going to list it as an ordered pair, -5, comma 0. Thanks, a good bonus question. Really all we're doing is we're taking the simplified form after anything divides out, if something does divide out, and we're looking to see what values make the numerator 0. You never want to call a whole an x-intercept because that would be silly, right? Because it's a whole, not an x-intercept. So that's why it's important to identify where the holes are first. All right, so we'll just call this for kicks and giggles, right? All right, any other questions on number 1? 9. Okay, number 2. Again, I'm already giving it to you set up, but just realize that I could say let g of x equal f over h, where f is the top and h is the bottom. Your first step is to write the equation g of x equals this. All right, number 1, factored form. I'm not going to go as quickly this time, but you factor it, it looks like that, right? Right after it's factored, what's the domain? You don't even have to set the denominator not equal to 0 anymore, right? You just look at the factored form like x can't be 8, x can't be 2. -8, sorry. Get that correct. Don't say x can't be 8, comma -2. Because now you're way off, right? Ooh, that's not good at all. If those are the factors, the roots are, again, imagine setting them each equal to 0 and solving. If you need to do it off to the side, that's fine. So again, your domain in set notation, they don't have to be in order. You could say x cannot equal -8, comma 2. That's fine. I saw Aiden did that over there. That's fine because those are listing x values. It's not writing equations of lines. And then interval notation, a little bit longer. Simplified form, it's the same, right? In this case, it's the same because nothing divides out. If nothing divides out, Brady, then nothing's removable. And therefore, those two values that are non-removable that make the denominator 0 are vertical asymptotes. So g of x has no holes. Again, that's what I would be looking for. My note to you on Friday in my absence was no factors divide out. So you're like, oh, that's why they're both VAs. G has VAs at, and now you do want to list these separately. Okay, list separately. Don't say at x equals -8, comma -2. Because you're not listing x values, you're writing equations of lines. Okay, you could do that though in the domain. I'm fine with that. Should be getting easier, right? All right, kicks and giggles. What are the 2 zeros or the 2 x-intercepts of f of x or g of x? -7 and -2. Since nothing divides out, the two values that make just the numerator 0 are the roots, -7 and -2. So you would say g, you would set this equal to 0, and then you would show me you're setting the numerator equal 0, and you'd say, okay, so g has x-intercepts or holes or roots at -7, comma 0, -2, comma 0. Okay. All right. Haben Sie Fragen? ¿Tienes preguntas? Any questions? No? All right. K of x is equal to that. So it's a cubic, but now the numerator is factored. I could give it to you fully factored or partially factored just to expedite the process. Factored form, there you are. Before you divide anything out, find the domain, right? Because we learned in class that if you find the domain after you simplify, you might get a different domain. Factor it. What are the two values that make the denominator 0? X equals 5, x equals -2. So x cannot equal those. That's the domain. X cannot equal those. Therefore, those are discontinuities. And therefore, either one of those may or may not be holes or VAs. They're independent of each other. You can have a function that has only vertical asymptotes one that has only holes, and one that has a combination of both. There's really no limit. In fact, if you like Swiss cheese, you can make your graph extra holy, right? Let's do that. Let's go ahead and add something here. Let's say I want to make a hole at x equals 10. What factor would I need to add here to make a hole at x equals 10? X minus 10 in the top and x minus 10 in the bottom. Congratulations. You just created a hole at x equals 10, right? Swiss cheese. So that's the idea behind that. You can have any number of holes, any number of VAs. You just take what's given, right? So once we find the domain, rewrite in simplified form. Well, notice your x minus 5s and your x plus 2s divide out. I didn't show the marks, right? Can you do that on the test? Sure. If you have a pencil and you don't obliterate it, you could say, as long as I can see what's underneath there. If I can't see what's underneath there, I'm not going to give you the benefit of the doubt. Because remember, the goal is to communicate. So if you don't need to do that, that's great. If you want to, I understand. So there's the simplified form. We're just left with x plus 7. You don't even need parentheses around it. But now you tell people, hey, don't use -2 and don't use 5. Because it's no longer built in. Function doesn't exist at -2 and 5. But notice the graph used to be the handsome algebra 1 line, x plus 7. That was defined everywhere. But Swiper came in twice, right? Maybe x equals -2 is Oklahoma and x equals 5 is A&M. And they came in and they stole a victory from the Longhorns and the Crimson Tide, respectively, right? 2 upsets there. Not upsets, but 1 upset and 1 crazy come from behind victory. All right? So tell people, don't use -2, don't use 5. Determine the coordinates of any holes. Now, again, I'm calling the simplified form y, just generic y. Indicate your method. Y of -2, y of 5. I'm plugging it into x plus 7. Easy. Now I'm answering in a complete sentence. And again, the highlighted part is what I'd be looking for in the test. K of x, the original function, not y. Don't say y. Now we go back to the original function. K has holes at -2 comma 5, 5 comma 12. No vertical asymptotes, 2 holes. And then K of x has no VAs. That's a complete sentence. If you want to put NA like that, would that work? That's fine. I'm okay with that. We all know that that means what? Not applicable, right? Or applicable, however you want to say it. Not applicable, not applicable. That's fine. This is better though, right? Because it's a complete sentence. K of x has no VAs, has 0 VAs or whatever, but NA is fine. All right, and then the last one was h of x. And it says h of x equals f of x. So we gave this guy 2 names, Fred and Harry, but whatever. That was a typo, but it doesn't matter what we're calling it. We're calling it h of x down below. Factored form. I'll just take away that legal name. Factored it. This is kind of like the first one now. Domain can be 5 or -1. Get rid of the x minus 5s, write the simplified form. Say x can equal 5. And now, does it have a hole? Well, yeah, the x minus 5 divided out. So plug in the 5 to the simplified form. And again, you're showing me how you're doing it. So y of 5, it equals 4/3. And now you answer the question. If you just stop at 4/3, if you just say y of 5 equals 4/3, you're not answering the freaking question. You're just doing some work. And you're leaving it to me to figure out what that work is supposed to indicate. That's why the so is so important. It's a transition. So you put so, which is a real blue collar word for therefore, right? You can say ergo if you want. Consequently, that's a longer word, right? You can even put the 3 little dots that mean therefore. Therefore, h of x, don't say it. Try not to ever use the word it in here. Pronouns are bad because we really don't know what the antecedent is. H or h of x has a hole at 5 comma 4/3. And then, of course, the factor that didn't divide out, the x plus 1, h of x has a VA at x equals -1. And for kicks and grins or giggles, whatever you prefer, h of x has a 0 or an x-intercept where? At x equals -3 or at -3 comma 0. Notice originally 2 values made the numerator 0, but both of them are not roots. One of them divides out, it's a whole. But the one that's left in the top gives you the x-intercept location. Okay, y'all could do that, right? On a free response? I know you can. Even though I wasn't here for 2 days, I was still kind of here by way of the World Wide Web. All right, I have this key posted on Canvas, so I would just go through it and check. If you got it wrong, fix it. I have a folder in Canvas for you to submit this once you get through all of it. So if you kind of refresh Canvas, I put graded in the front this time because I think what happened last time is I put graded at the end and it shows up on the back end of y'all's. And some people submitted their previous assignment that was graded into the first assignment. So I put graded Thursday reviews for tests. And I just want to see you having gone through it. You know, I'm not going to take this for like a correction or an accuracy grade because I wasn't here. But I want to make sure that you've gone through everything. I want to make sure that you've checked, reconciled your work against the key. How about that? So instead of graded, maybe it should say reconciled, but that's too many letters. So once you're done, and this you have till 4 o'clock today to submit this. I'm going to go in there and see that you've accounted for everything. Maybe you've made corrections, taken some notes on what I've said today. Yeah, perfect, perfect. I just want to see interaction. I want to see correct answers. That's good. I'm just going to go through it quickly. I mean, that's all I really look for. It loads. I flip it through from high to low, make sure that it's all there. Try to memorize what the handwriting looks like in case it shows up the same handwriting in another document, and then I can give you both zeros and throw you out of NHS if you're in there, you know, but I don't have to do that, right? We never went over integrity, but I did have you read that article at the beginning of the year. Yes. The key, did it not post? Oh, I put it under announcements. Thank you. Thank you. Announcements. I did it under announcements because I thought maybe you would get an alert on your end when I put something in announcements. So yeah, thank you. All right, so real quickly, I just want to, again, go over all of these were linear under a radical, except for 13, but that was didn't matter because it was a fifth root. But just remember, like if you see something like h of x equals like the square root of, let's just take the same one, x squared minus 25, and you're trying to find the domain. Don't say x squared minus 25 is greater than or equal to 0, and then x squared is greater than or equal to 25, and therefore x is greater than or equal to -5, and x is greater than or equal to 5. Okay, if you do that, I'm going to probably take off more than 1 point because that's trying to solve it algebraically. What should you do? You should identify the roots, right? X minus 5, x plus 5, greater than or equal to 0. I don't even care if you list the roots. I just want to see the graph. Here's -5, here's 5. Does your parabola open up or down? It opens up, right? And I want to know where is it greater than or equal to 0. That's positive. So it's going to be, in this case, outside. X is less than or equal to -5, or x is greater than or equal to 5. So the inequality does not face the same way. That's not good. It's either going to be between them if your parabola opens down, that's where it's positive, or outside of them if your parabola opens up. So there are a lot of people, when I was looking at that previous worksheet, we're just solving quadratic inequalities just willy-nilly, I guess, if that's a phrase that y'all can resonate with. You've got to sketch the graph of the parabola. It's going to be either outside the x-intercepts if it opens up, or below, between the x-intercepts if it opens down, sorry. Okay. All right, we only have about a minute left. So remember that there are old tests. There's a link in Canvas. There's also a link on Corpy's World. It's open 24/7. Old tests. We're going 1.1 to 2.1 again. So there's still two tests there, but you can look at 1.1 through 2.2. There's still some stuff from 2.1 down below to 2.3. If you want to go through those, we'll probably just pull questions from other tests. And remember, there's not going to be any absolute values, and there's not going to be any of those piecewise functions with that open brace. It's just through discontinuities, okay? I'll be here in the morning. at 7:30. So if you can sneak in or come in when the doors open, I'll be here. I do have duty today after school, but it's at the training door exits on the back. So if you have a question, I'll have the doors open, the music blasting, but we can answer questions over the roar of the music and the chillers outside that are roaring to keep this school nice and comfortable for us to think. Yeah. All right. Comments, questions? All right. That was perfect timing. Y'all can get a head start to the stairwell. Have a splendid day. There you go. Not much of a head.